Hello everyone and welcome to ENL 582, Modeling and Control of Electric Machines and Drives for the semester fall 2021. I hope you are all doing well and staying safe during these circumstances. And I hope you're enjoying your semester. So my name is Mohammed Al-Muzain. I am a fourth year PhD student and I'll be very happy to be your sessional instructor throughout this course. So that's my third time teaching this course and I have to say it, I enjoyed so much teaching this. Electric machines has been, as a teaching, research and everything, has been my whole academic career. So my bachelor degree graduation thesis was about the control of three-phase induction machines working with elevator systems. My master's degree was about the design and modeling of a special type of synchronous machines working with wind energy applications. And my PhD is working mainly about modeling of electric machines connected to the public electric grid. So actually teaching, studying and researching electric machines is the passion of my life. I love electric machines so much and I really hope by the end of this course you will love it as much as I do. So I need just in this very short introduction about the course is to get you in line about the course, what we mean about electric machines, what we'll be teaching and studying together throughout the course, and how the course will be managed and everything. I hope this short introduction will be very helpful to introduce you to the course and how everything will be just run around the semester. So if I need to start before doing anything else, I need just to give you an idea what we mean by an electric machine. So electric machine, okay? So electric machine by definition is an energy converter. So it's a device that converts energy. So if you have this device here and your input is electric energy and the output is mechanical energy, so this machine we call it a motor. Okay, so it's a machine, but it's a specific type of machine which is the motors, which is basically used to convert electric energy into mechanical energy. So mechanical energy we mean by rotation. So the motor simply is just this device. When you plug it into an electrical source, it rotates, and whatever attach it to the shaft of this motor will rotate with it. Whatever you're talking about, a fan, a pump, any kind of production line you're trying to have, your elevator in any building, so that's what we call about a motor. Okay, on the other hand, if you have the input to this machine, so here's our input, will be mechanical energy. To be more specific, I'm talking here about rotation, just to have in mind what we're talking about here. So the mechanical energy you're talking about here is rotation. Yeah, there is special types of machines where this is not really rotation, but it will be a linear movement, but that's not the type we're talking about. We're talking about the more very well known and type of machines that you will be just seeing at all your work sites and every place, and even at your homes. We're talking about rotating machines here. So if you input a mechanical energy, you rotate the machine and your output will be electrical energy, and this type of machines we call it a generator. Okay, so electric machine is an energy converter, something that converts between electric energy and mechanical energy. So if it converts from electric energy to mechanical energy, that means we give it electricity and it rotates. That's a motor. If you apply mechanical power to it, that means you rotate it by an external mean, it will develop or generate electricity, and that's what we call a generator. Okay, at both of those machines the medium for this energy conversion is your faithful friend throughout the course and every time, which is the magnetic field. So the medium that holds this conversion between electricity to mechanical energy in a motor, or between mechanical energy to electricity in a generator, is your magnetic field. Okay, so these types, the motors and the generator, we specifically call them electromechanical energy converters. Okay, why we are specifying that electromechanical, that means they convert between electricity to mechanical energy or mechanical energy to electricity, because actually your well-known transformer, which you should have been just had a good idea about it in previous courses, if you remember this type, the electric transformer that is used to step up the voltage or step it down, we also consider this as a machine. And why we're doing this, there's no mechanical energy over here. The transformer does not rotate by any means, but actually to step up the voltage or step it down, yeah, so here is electricity and here is also electricity. So this electric energy as output and also electric energy as input. Okay, but we call it a machine because this transformer is used to step up or step down the electric voltage, and to do this you have to convert the electric energy to, again, our medium, which is the magnetic field, and then back again to electric energy. But now this electric energy with different characteristics. What I mean different characteristics? So you stepped up the voltage or step it down. So actually that's why we are just considering this a machine, because it has to have a magnetic field. Okay, so actually this involved energy conversion. So this electrical energy you having here as input is being converted into magnetic field, magnetic energy, and then back again into electric energy. So that's why we call this a machine, because it's also an energy converter. Okay, but the transformer is out of our scope in this course. We mainly interested with this type, which is the rotating electric machines. So we're talking about the electromechanical energy converters. This machine, those machines that involves movement, involves mechanical energy manipulation. Okay, so in our course we'll be dealing just with the motors and the generators. We will not be looking at transformers, but it's worth mentioning that a transformer is also considered a machine because that's basically an energy converter. Okay guys, so throughout the course we'll be talking about motors and generators. Okay, I know that throughout the courses before that you dealt with in university, you have been just subjected to something like this. Okay, so you've been seeing a control circuit, some sort of power electronics or electronics, and you have talked about this before in different courses, and they say, come on, that is a motor. Okay, and that's something that if you plug it or just apply some sort of electricity to it, it will start rotating. So all the time we've been dealing with this as just a black box, okay? So you've seen before, you've used it before, but you didn't know what's happening inside it or how it works actually. Also in your power system courses, if you have subjected something like that, you have seen what we call a single line diagram like that. And they're all the time talking about the transmission lines and the electricity moving in the public grid and all that stuff, and just saying to you that this guy, and those guys are basically generators. And they are saying those devices just generate electricity that we try to transmit and distribute throughout the public grid to reach the customers. But again, we've been dealing with all the time with these kinds as just black boxes. You don't know how this particular machine is working or how it generates electricity. So my main goal in this course is to unlock these black boxes, to look what's inside the motor and the generator, and give you the idea of how these devices are working, to model them, to look into them, to know how they're constructed, how they built, how they work, and how they do the job. How this magic, the energy conversion, happens inside this machine. How we get this device and plug it into electricity, it will start rotating. Or how if you get this generator and just apply rotation to it, it will eventually give you electric voltage and current out of the terminals of the machine. This is what we call energy conversion, and that's the main goal of the course, is just to unlock these black boxes and let you know what's happening inside of them. So electric machines, it's all started far away by the genius Michael Faraday. Okay, so this guy was just investigating the relationship between electricity and magnetism. It's all started, it's just when you look at this magnet, is just have a north pole and south pole. We've seen it so much, and we know that it's basically having magnetic field and magnetic flux lines coming from the north pole going back to the south pole. Okay, Faraday has just seen this. If you grab a piece of wire and just make it a loop like this, okay, and you apply some sort of electricity to it, okay, and you have electric current going through here. So electric current going through this coil, it will transform this coil also into a magnet, which having north pole and a south pole, and it will start acting just like this natural permanent magnet, okay, and he called this electromagnet. And this actually unlocked a very, very, very big advantage, because the permanent magnets, basically you cannot easily control them. You cannot control the amount of magnetism that coming out of them. It's basically a permanent magnet. It's just something you have it with specific shape, with specific design, a specific magnitude. But if you're talking about electricity that going through a coil, you have full control over the electricity. You can control its magnitude, its direction, so you can play with the magnitude of this magnetic flux and its direction, so you can basically reverse these poles if you want. If this north, but you want it to be south, you can do it. So this can be south and this can be north if you want. You can do this with the permanent magnet. So this flexibility has just unleashed a very big potential about the application that can be played with using this principle. Faraday continued working about this and just figure out those two magnificent principles. If you have a permanent magnet like this and you started just moving it throughout the coil, okay, up and down, he just noticed that this coil will have an electric voltage induced on it. That means this movement of the permanent magnet, or this magnet inside the coil up and down, will basically generate electricity on this coil. That's how the nature works, okay guys? And that's how he developed, just if you have magnetic field and you have movement, so we're talking here about movement of magnetic field across a coil, will basically generate electricity. Again, it's movement of the magnetic field into this coil. It's not just having magnetic field near a coil. It has to be changing magnetic field. It cannot be fixed. Okay? Will generate electricity. And they call this the generator action. Okay, guys? That is the generator action. At the same time, if you have a piece of wire just like this and you have an electric current moving into it, okay, so that's electricity moving into it. It's coming from an external source. You have a battery or anything connected to this wire, so you have electric current moving into it. And at the same time, you have a source of magnetic field, something like this permanent magnet, which is north and south pole. So you have magnetic field here. So you have the combination of them. You have a wire that's carrying electric current and placed inside a magnetic field, that this wire will start to have movement, mechanical movement. Okay? By some arrangement we will just be able to transform this translational movement, linear movement, into a rotation. But this is a principle that if you have a piece of wire carrying current, electricity, and place it into a magnetic field, it will move. Okay? And this what he called a motor action. And this is how the birth of both the generator and the motor, from the very basic experiments done by Faraday. Okay, these has been evolved so much since then, and the engineers have played so much magnificent role transforming this into vast variety of these machines, the motors and generators, with different principles of operation, with different capabilities, with different characteristics to be used with different applications. You will see them as small as the very small motor you can see driving the fan, cooling fan of your laptop, up to giant electric motors that need specially designed trucks to carry them. And you find the generators from as small as the very small generator attached to your bike wheel to generate just enough electricity for your flashlight, up to the very big large size synchronous generator that use in power plants. That's how it's compared to the size of a man. So that's the generator we're talking about here. That's a very big machine. So these machines you'll be finding all over around you. You can find the electric motors in your very small home appliances, from the fan to the refrigerator and much more, up to all the production lines you can see out there. So electric motors used everywhere. It's a very, very important asset in modern day civilization. Also, electric generators is basically how we get electricity to our homes, to our factories, to our commercial applications and commercial activities. So electric machines, guys, is just something inevitable to just deal with, study, model, design, and control. And that's how we try to do all over this course. We try to open up these devices and see what's happening inside, how they're being constructed and how they work, how we model them, how we study them, how we can expect this performance and calculate their performance and say if they're working good or not, they're working in a proper environment or not. So that's what I need to do throughout the course. Today I wasn't just trying to make you know what electric machines are. It's just a very short introduction to know what we are talking about here. Okay, so if you ask me what this course for, or what the type of student that needs to take this course, so I'll be saying that we have two types of students that I so much recommend to take this course and study it well. The first one is an electric engineer in general that needs to work in control or in electronic design, or just working in power systems and just will be dealing with machines all the time. So any kind of electric machine actually has to have a very deep introduction and a very good introduction about the fundamentals of electric machines and drive systems. So this is the perfect place to just unlock the black boxes we're talking about at the first and see how actually these devices work, the motors and the generators. Okay, that's very important, because if you will be dealing with designing the control system, or just be a programmer that will be learning about robotics or any industrial designs, or be a power system engineer that will be working in the public grid dealing with generators and motors all the time, you need actually to have a good understanding of these machines and how it works. It will make a huge difference if you deal with these kinds of devices while you understand what's really happening inside them, not just dealing with them as black boxes. The other type is a student that's really planning to be working with electric machines throughout his life. So he will be an electric machine designer or electric machine operational engineer in a factory that's taking care about these kind of devices and all the time. So this course will be a very, very good first step for him. After this course, he will be very confident to pick up a very large textbook or a catalog and just look into it, and he will just walk, or just he will be very able to walk through it and understand what's happening and grow his information time after time. So I really enjoy electric machines, and I find them actually, guys, the perfect place to see the theories of physics you've been studying all the time since your high school and into your early university years. Here, the place where you can see these theories come true and really see how the magnetic field and electricity, they interacting together to develop movement in motors or to develop electricity in generators. And that's so much rewarding if you see what I mean. Okay, guys, so we'll be looking into the machine, see how these kind of machine are constructed in as much detail as we can go through. Okay, so by the way, that's called an induction motor, a three-phase induction motor, and it is the workhorse of industry actually. So you cannot find a factory without three-phase induction motors into it. Okay, we will try to look inside these kinds of devices and see how actually they're built from inside out. Okay, and the more important thing, we'll be studying the theory of operation, how these machines work, how this kind of machine transforms electricity into movement or movement into electricity. Okay, throughout this we'll be dealing so much with equations, modeling,